Previously, we learned how to make line plots using Matplotlib. In this chapter, we'll learn about several additional plot types, starting with scatter plots. We now know that Freddy Frequentist is the one who kidnapped Baze, the golden retriever. Now we need to learn where he is hiding. Our friends at the police station have acquired cell phone data, which gives some of Freddy's locations over the past 3 weeks. The locations are given as a set of X and Y coordinates on a map. In order to visualize these coordinates, we'll use a scatter plot. A scatter plot allows us to show where each data point sits on a grid. Line plots let us visualize ordered data points, but scatter plots are a great way of viewing unordered points. For example, suppose we want to learn about how golden retrievers grow during their first year of life. We might measure the heights of many puppies of different ages. We could then plot the height of each puppy versus its age. In Matplotlib, we create scatter plots using the command plt.scatter. The first argument is the x data. In this example, the age of the puppy. The second argument is the y data. In this example, this is the height of the puppy. We can then add labels and use plt.show just as we would for a line plot. Many of the same keyword arguments that we used in line plots will work in scatter plots. In this example, we use the keyword argument color to change the marker color to green, and the keyword argument marker to change the marker shapes to squares. If we try to plot many plots on the same scatter plot, things can get chaotic. We can't see if we plotted many layers of points or just a single layer. We can make it easier to read by using a new keyword, alpha. Alpha accepts a number between 0 and 1 and makes each marker transparent. The smaller the alpha parameter, the more transparent the dot. Now we know that the darker areas have many points, while the lighter areas have fewer points. We've learned a new function, plt.scatter. We can use it to plot two-dimensional data. We can use many of the old keyword arguments that we learned for plt.plot, along with a new argument, alpha, which controls transparency. Let's practice. Previously, you learned how to make a line plot and a scatter plot using Matplotlib. In this lesson, you will learn how to make a bar chart. Officer Deshawn wants to examine the average number of pet kidnappings per month across different precincts. The best way to visualize a comparison of categorical data is by using a bar chart. Creating a bar chart in Matplotlib is simple. We simply provide 2 arguments to the function plt.bar, the labels for each bar and the height of each bar. Because the x-axis is labeled for us, we only need to add a label for the y-axis using plot.ylabel. We can also make a horizontal bar chart. We simply use the function plt.barh instead of plt.bar. When we have many bars, it can be easier to fit all of the labels in with a horizontal bar plot. In the previous exercises, we've been plotting the average number of pets kidnapped per month. Averages don't always tell the full story. Often we'll want to show some sort of error associated with our average, such as the standard deviation or standard error of the mean. We can add error bars to our bars by using the keyword argument yerr after the first 2 positional arguments in plot.bar. In this case, we are filling in yerr with a column of our data frame called error. We know that Cityville had more pet kidnappings than either Farmburg or Suburbia. Officer Deshawn wonders if this is true for both cat and dog kidnappings. The best way to compare both cat and dog kidnappings while also displaying the total number of kidnappings is to use a stacked bar chart. In a stacked bar chart, we display 2 different sets of bars. The height of each blue bar represents the number of dogs kidnapped. The height of each orange bar represents the number of cats kidnapped. The total height of the blue and orange bars represents the total number of pets kidnapped. To create this stacked bar chart, we start by plotting the dogs column as we normally would. Here, we'd show just one of the columns, which starts at y = 0 and has a height of 4. Next, we stack the cat bar charts on top of the dog bars by using the keyword bottom. Normally, a bar chart will start each bar at 0, but if we add the keyword bottom to plot.bar and feed in the heights of our bottom bars, in this case df.dog, Matplotlib will pop the second set of bars starting where the first start of bars ends. For this particular bar, the cat bar starts at a height of y = 4 and ends at a height of y = 10. The height of the orange bar alone is 6. This is our complete set of code for creating a bar plot. Notice that we also added the keyword argument label for each bar plot to create our legend, just like we did for our line plots. You've just learned how to create a bar chart, add error bars, and stack bar charts to make comparisons. Let's practice. Previously, we learned how to make line plots, scatter plots, and bar charts. In this lesson, we'll learn how to make one last type of plot, a histogram. Freddy Frequentus left a dirty shoe print at the scene of the kidnapping. In that shoe print, there were many tiny pieces of gravel. Our crime lab was able to give us a pandas data frame with the radii of each piece of gravel. We want to compare the distribution of gravel radii to samples from the 3 sites where Freddy could be hiding bays. If the distributions match, then the gravel in the footprint came from that site, and Freddy is likely hiding there. The best way of visualizing the distribution of gravel radii is by creating a histogram. A histogram visualizes the distribution of values in a dataset. To create a histogram, we place each piece of data into a bin. In this example, we've divided our data into 4 bins: 1 to 10 millimeters, 11 to 20 millimeters, 21 to 30 millimeters, and 31 to 40 millimeters. The histogram tells us how many pieces of data, or pieces of gravel, fall into each of those bins. When we look at a histogram, we can quickly understand the entire dataset. Plotting a histogram in Matplotlib is easy. We simply use the command plt.hist. This function takes just one positional argument, our dataset. The output is shown on the right. By default, Matplotlib will create a histogram with 10 bins of equal size, spanning from the smallest sample to the largest sample in our dataset. If we want to change the number of bins, we can use the keyword argument bins. Bins accepts one integer. In this case, we divide our histogram into 40 bins. This allows us to see more detail in our histogram. If we want to zoom in on a specific piece of our dataset, we can use the keyword range to set the minimum and maximum value for our histogram. Note that we give the minimum and maximum values inside of a second set of parentheses, separated by a comma. In this case, the minimum value is 50, and the maximum value is 100. Suppose we wanted to compare the distributions of weights of male and female puppies. For some reason, we were able to collect many more samples of male puppy weights than female puppy weights. When we plot both histograms on the same axis, we can't actually see the difference in the distributions. In this case, we don't actually care about the absolute number of male puppies with a given weight. Instead, we care about what proportion of the dataset has that weight. We can solve this problem with normalization. Normalization reduces the height of each bar by a constant factor, so that the sum of the areas of each bar adds to 1. This would make our 2 histograms comparable, even if the sample sizes are different. We can normalize our histogram by using the keyword argument density equals true. Now, each bar represents a proportion of the entire dataset. If a bar from the male puppies has the same height as a bar from the female puppies, both bars represent the same proportion of each population. Now that you've learned how to create histograms, let's practice by identifying where Freddy Frequentus is hiding. Congratulations! You found that Freddy Frequentist kidnapped Baze the Golden Retriever and was hiding him at the Shady Groves campsite. Baze was safely returned to his Datacamp family. Now that you've solved the mystery of Baze kidnapping, let's recap what you've learned. First, you learned about modules. Modules help group together related tools in Python. You can use a module by importing it at the top of a script file before writing any other code. You also learned about variables as you filled out Baze missing puppy report. Variables store data. Two common types of variables are strings, which represent text like Baze fur color, and floats, which represent numbers like Baze age. Next, you learned about functions. Functions are like machines that turn inputs into outputs. They can take positional arguments, which must come in a specific order, or keyword arguments, which come at the end and can go in any order. You used a license plate lookup function to get your first list of suspects. You narrowed your list of suspects by using pandas to examine credit card records. Pandas is a module that uses tools like data frames to examine and modify tabular data. You investigated the credit reports using functions like head and info, and selected specific rows that corresponded to suspicious purchases using logic. After narrowing the suspect pool down to 2 people, you collected handwriting samples and analyzed them using line plots. Matplotlib is a module for creating charts and visualizations. You used the plt.plot function to create line plots and used keyword arguments to modify the color and line style of your plots. You used functions like plot.legend and plot.title to add annotations to your plots. Line plots of the handwriting samples helped you learn that Freddy Frequentist was the kidnapper. You learned to create several other plot types using Matplotlib. You used a scatter plot to investigate cell phone data and narrow Freddy's location to 3 possible campsites. You used bar charts to track how Officer Deshawn and his friends used their time to solve the mystery. Finally, you used a histogram to examine the distribution of gravel radii on Freddy's shoe print. This helped you determine that Baze was being kept at the Shady Groves campsite. You learned a lot while solving this mystery. Now you're familiar with the basics of data analysis in Python. You can start learning other skills like machine learning or data visualization. Good luck!